Wait a minute. Let me think about this more. No, it's still minus. Oh, I don't know. Fine, I'll work it out. You guys doing to me. Well, I'm just going to stop there. I mean, and so forth and so on. You can do partial fractions and finish this, right? And the thing is, well, I mean, the thing is, yeah, the Weierstrass is I mean, you know, it's a machine, right? It's a beast. It's not like the things we did before. This is like very general. Any rational function of sine and cosine, it will convert to a rational function in U, which you can do partial fractions on. Yeah, you could do secant cubed with this. It would just give you some, hey, oh, what does that do? Now, oh my goodness, that's a very interesting question. That is a fantastic comment. I should behave, though. Are there other homework questions before I waste? But that, I mean, this is just dawning on me because I haven't made the Weierstrass substitution a central part of my teaching. But as I think about it more logically, as it starts to dawn on me, goodness, it really should be, because it's so general. Any rational function of sine and cosine, it just destroys. But I suppose the things we did without the Weierstrass substitution earlier might have been easier. I mean, there's kind of a lot that goes, the thing is, there's a lot that goes into that. You're like, but once I have a sledgehammer, I want to use it. Like, well, even on mosquitoes? I mean, I don't know. I guess you can. Actually, mosquitoes are kind of dodgy. You really want one of those. You know those like the tennis rackets, but electrified. Oh yeah. Everyone should have one of those. They're also good for spiders. I have not tried it on a cat. What? Cats are annoying. No, squirt guns are good for cats. Or if you got a baseball to throw at it or something, I don't know, whatever. But oh, okay, I'm sorry. There a homework question? Yes. 8.5 number what? 47. Sorry if I have squandered some of your time today. Tomorrow I will have the whole time for your homework, so. 8.5 number what? 47. I so soon forget. Man, you guys ask about hard questions. What? Wait. The earlier section asked me easier questions. They're nicer to me. You guys are mean. They're just lazy. I'm going to tell them you said that. See here, C plus 2U. Ooh. So you're supposed to calculate this with different conditions. So, well, this is 46 and 47. So like 46 is this, 47 is this. I think these are kind of part of a larger story. AD equals to BC versus AD not equal to BC. What's the significance of those algebraic conditions? Very interesting. See, I guess what I'm trying to tell you guys is I used to think that by not teaching the Weierstrass substitution, I was making it easier. I'm actually starting to think that that's wrong. Having something that always works is very comforting, right? Although it does come at a price. Algebra. All right. So you got 1 over a plus bu times c plus du. You're trying to understand algebraically what is that. If you don't mind, I'm going to change this to x so that you guys understand it better. It's a fact of mathematical psychology that x, which is the only kind I care about, is easier for you guys to handle. Oh, this is awesome. We're also given, you're saying? Sorry. U is a variable. You could make it x. It's the same question. But you guys will follow my algebra better if I make it x. So if a, b, c, d are not equal to 0, right, that means we can divide by them, right? So I can factor out what? A b. And I can factor out of this one a d, right? And so what does that do? BD. Now what are the possibilities here? Either those linear factors are distinct or they're not. In other words, it's either distinct or it's a repeated linear factor. So in other words, there are two cases, right? The two cases are that x plus a over b is actually equal to x plus c over d. It's the same factor. Or x plus a over b is not equal to x plus c over d. This gives me what? Cancel the x's. AD equals to BC. Cancel the x's. This gives me AD is not equal to BC. The case that they're not equal is the case of distinct linear factors. The case that they're equal is the case of repeated linear factors. And from there, you should be able to integrate. Right? The difference in those the repeated or distinct is the partial fractions decomposition is different, right? Like, if they're equal, that means the partial fractions is something like what? It's a over x plus a over b plus b over x plus a over b quantity squared, right? On the other hand, this one would be something like a over x plus a over b plus sorry, capital A, capital B. I hope you can understand the difference. It's a little, not fine. I'll put some tildes on it. Is that better? Okay. And so those are different possibilities. And then you can integrate. I mean, that's the outline. Other questions? Yeah.
That we just move 1 over BD to the outside of the integral sign, right?
The reason I can do that is because I'm given this, thankfully. Yeah. I think I can get away with this question still even if I just know that B and D are non-zero from what I calculated. But I think they made them all non-zero so that there are other derivations possible. Yep.
So the du, like calculated
Oh, yeah.
the du in the numerator is
Oh, yes. Yes. Oh, that's funny. Yeah, no. This is a very unfortunate. So usually context saves you this degeneracy of notation. No, these are not the same thing. No. Ah, interesting. But, I mean, I guess I would follow that up with, what would we even mean by that if that was a differential in the denominator?
Yeah, no.
There is some meaning to be had in the classical theory of differentials, but that's not something we really incorporate into the calculus sequence so much anymore. You could ask Newton in terms of fluxions or something. That's really old school. Let's see here. That's a very good question. No. Oh, so there's a really good reason to make it x instead of u. Oh, wait a minute, same problem. Then it's dx and dx, top and bottom, right? Change the d. Yeah. Can't use d as a variable. Okay. But there are other algebraic reasons to want to write ABCD there. As this question appears in algebra other places, it's traditional to use ABCD in this way. So oh, yeah. Sure. If it's bothersome, that's the simple solution, is to make this A, B, C, D. Although I do have some bad news for you. In differential equations, we have y prime plus y is equal to e to the x. We soon write that as L of y is equal to e to the x, where L is equal to d squared plus 1. Ooh, it's the derivative. No. So your satisfaction with me using a capital D here will be short-lived. Once you get to differential equations, you will then be, again, disturbed by the notational degeneracy. There's only so many letters to go around. Until we all learn Chinese, we're stuck with these problems, you know?
Let's see when D on top be italicized.
Italicized. Yeah, put a bar on one. I don't know. Do you guys have other questions? All right, let you go a couple minutes early. How about that? Yeah. Thank you.